Hello everyone. Today let us discuss the problems related to second order derivative which are very important for your exams. Okay? So if you like this video, please don't forget to subscribe my channel. Don't forget to like this channel. Hello everyone. Today I am discussing the exam essentials. Okay? So that took 5 marks, differential calculus, 5 marks. The question is, as I have written on the board, y is equal to sine inverse x. Show that 1 minus x square d square y by dx square minus x into dy by dx is equal to 0. This is actually the problem comes under the second order derivative. That means you must differentiate the function twice. Okay. So if you differentiate the given function y twice, you will get the second order derivative. Okay, so let me solve this question. It's a very easy question actually, and also it carries 5 marks. Let me see how to do this. The given function is y is equal to sine inverse x. Okay, so I will differentiate this with respect to x. So if you differentiate this with respect to x, y derivative, that means differentiation with respect to x, is dy by dx. We know the derivative of sine inverse x, that is 1 by root of 1 minus x square. See, that is what I have done here. Just I differentiated the function y is equal to sine inverse x. This is the first order derivative. Okay. See, observe here what we should get: 1 minus x square d square y by dx square minus x into dy by dx. Isn't it? So it means again we must differentiate the function. See, what I will do here, I will take the right hand before differentiating second time. I will cross multiply the right hand side denominator to left hand side. So see here, this is what I will do. I will take this to left hand side. Okay. So if you take or if you cross multiply that to left hand side, what it becomes? Let me see. If you multiply root of 1 minus x square to left hand side, it becomes root of 1 minus x square into dy by dx equals 1. 1 is remaining as it is in the right hand side. Okay. So now I will differentiate with respect to x. So now observe here, we are having the two terms. See, this is the one term and this is another one term. Product rule we should apply. What is that product rule actually? Derivative of u into v. Product rule. The first function into derivative of second plus second function into derivative of first function. This is what product rule I'm applying. Okay. So let me apply here u and v. U is equal to what? Root of 1 minus x square. V is equals to, V is dy by dx. Okay, so don't be confused. What I have written, keep it in mind and let us do the differentiation. First function as it is, we must write root of 1 minus x square into d by dx of v. The second function is dy by dx. If you differentiate that again, you will get the second order derivative, that is d square y by dx square plus second function is dy by dx. I am keeping that as it is, dy by dx into derivative of the first function. See, root x. This is in the form of root x. Root of 1 minus x square is in the form of root x. Root x derivative is 1 by 2 root of 1 minus x square. See, chain rule you must apply there. First, we took the root. Whatever we are having inside, you keep that as, or you consider that as x. So it is in the form of root x. Root x derivative is 1 by 2 root x. That is over. Next, within the root, what we are having? 1 minus x square. Let me differentiate that. After differentiating, 1 derivative is 0. The x square derivative is 2x is equal to, in the right hand side, we are having 1. 1 means it is a constant. Constant derivative is 0. Okay, so now what we should do, see here, actually this 2 and this 2 both will get cancelled. Okay, so in the denominator of the second term we are having root of 1 minus x square. So root of 1 minus x square, I will take it as a second LCM. Okay, so if you take that as an LCM, what we can write that root of 1 minus x square is the LCM. If that is the LCM, you cross multiply that for the first term. It becomes what? Already we are having 1 minus x square. So if you multiply that with root of 1 minus x square, it becomes whole square into d square y by dx square plus, sorry, minus, this negative comes outside, minus x into dy by dx equals 0. So when you cross multiply this to right hand side, it becomes 0. So now I will write out the remaining terms. Square and root both will get cancelled. So finally 1 minus x square into d square y by dx square minus x into dy by dx is equal to 0. So this is what actually the proof what they have asked. Okay. So I think you have you have understood this question. Okay, so if you have understood properly, you please subscribe my channel. Now let us discuss the second question, that is, if y is equals to tan inverse x whole square, then show that 1 plus x square whole square into y2 plus 2x into 1 plus x square y1 is equals to 2. See, observe that actually y2 y1 means instead of giving y1 has dy by dx and y2 has d square y by dx square, they have given. Okay, so don't be confused in this question. Instead of giving d square y by dx square, they have given y2. Instead of giving dy by dx, they have given y1. That is the only difference. So let us see the proof of this question. See, the question is y is equals to tan inverse x whole square. Okay, so in the power we are having square. So let me differentiate. Let me find out the first order derivative. So differentiate with respect to x. Compulsory. See, actually in this, you must write this step. Very important. Differentiate with respect to x. So if you differentiate y with respect to x, what you will get? You will get first order derivative. That is dy by dx. Observe that it is tan inverse x whole square. So you must consider tan inverse x as x. Then it comes to the form of x square. You know x square derivative. X square derivative is 2x. So it is 2 tan inverse x. See, chain rule one after the other. First we consider the power and then the function. See, by considering the power we have got 2 tan inverse x. Now the function is tan inverse x. We know tan inverse x derivative is 1 divided by 1 plus x square. Okay, so observe there I differentiated the power first and then the function tan inverse x. In this, the denominator we are having 1 plus x square. I will cross multiply this 1 plus x square to left hand side, because see in the answer they have asked 1 plus x square whole square we must get. So that's why I will cross multiply this 1 plus x square as it is in denominator to left hand side. So if you differentiate that to left hand side, let us see what I will get. It is 1 plus x square into dy by dx equals 2 into tan inverse x. This is what we will get. Now, now I will differentiate, I will find out the second order derivative. So let me differentiate as we are having the product of two functions. See, this is the one function, this is another one function. I will apply the product rule. So 1 plus x square. As you know, in the previous problem, we have done the same thing. We have applied the product rule there also. The same thing I am repeating here. Okay. So first function into derivative of second plus second function into derivative of first function. 1 plus x square derivative is, what is 1 plus x square derivative? One derivative is 0, x square derivative is 2x. In the right hand side, we are having 2 tan inverse x, 2 constant. Keep that constant as it is. Tan inverse x derivative is 1 by 1 plus x square. See, again in the denominator of right hand side, we are having 1 plus x square. We don't want this in the right hand side. See the answer. In the right hand side, we want only 2 in the right hand side. So, we don't want this denominator term. Again, what you should do, you just cross multiply this to left hand side. For both the terms, if you multiply that, what you will get? 1 plus x square, already one term is there. If you multiply that with the 1 plus x square, it becomes whole square. Into d square y by dx square can also be written as y2 plus 2x into y1. Before that, I am multiplying 1 plus x square into y1 is equals to 2. So this is the final answer what they have asked. See, even this also for 5 marks. The first step, for this step, you will get 1 mark. For cross multiplying, 1 mark. Okay. Again, differentiating and finding the final answer. Totally, it carries the 5 marks. Very simple. Every step carries 1 mark. So very easy to score 5 marks. Okay. So I think you have got this question properly. Still, if you have any doubts, you please put in the comment box. Okay, so please subscribe my channel. Let me discuss the next question. So next question, if y is equals to 3 into cos of log x plus 4 into sine of log x, then show that x square y2 plus x y1 plus y is equals to 0. So let us see the proof of this. Even this is also very simple question, even which carries 5 marks. Okay. So let me consider the given function y is equals to 3 into cos of log x plus 5 into, plus, sorry, 4 into sine of log x. This is the question. Okay. So let me differentiate this with respect to x. Differentiate with respect to x. If you differentiate y with respect to x, we will get dy by dx equals 3 constant. Keep that as it is. Cos of log x derivative is minus sine of log x. I am applying the chain rule for this. Minus sine of log x into log x derivative is 1 by x plus 4 into sine of log x is cos of log x. Log x derivative is 1 by x. See, in both the terms, the denominator is x. So I will take the LCM. LCM for these two is x. After taking the LCM, let me find out minus 3 sine of log x plus 4 into cos of log x. So this is what actually, even you can take dy by dx, or even you can take this as y1. If you cross multiply x to left hand side, it becomes x into y1 is equals to minus 3 sine of log x plus 4 into cos of log x. So we want the second order derivative, isn't it? To find the second order derivative, let me differentiate this again with respect to x. So to differentiate the left hand side, we must apply the product rule. First function into derivative of second plus second function into derivative of first equals minus 3. It is a constant. I will keep this as it is. Sine function derivative is cos of log x into log x derivative is 1 by x plus 4 into cos of log x derivative is minus sine of log x. Next, log x derivative is 1 by x. See, observe that even here the denominator is x. So the LCM will be x. So after taking the LCM, what we will get, even in both the terms, I will take the negative common. If you take negative common, it becomes 3 cos of log x plus 4 sine of log x. Okay, see, observe that if you observe this properly, the given question is also in the form of 3 cos of log x plus 4 sine of log x. Even here, I will take this x, or I will cross multiply this x to left hand side for both the terms. We are having two terms in the left hand side, isn't it? That is xy2 plus y1. So if you cross multiply, it becomes x square y2 plus xy1 is equals to, the right hand side we can replace it as y. If you take minus y to left hand side, we will get the thing what they have asked to prove. That is x square y2 plus xy1 plus y is equals to 0. This is what actually the proof. Okay, I think you have understood the problem. The fourth problem, if y is equals to a into e to the power of mx plus b into e to the power of nx, Then show that d square y by dx square minus m plus n into dy by dx plus mny is equals to 0. So let us see the proof of this. So consider the function y is equals to a into e to the power of mx plus b into e to the power of nx. Let me differentiate this with respect to x. So dy by dx equals a constant, keep that constant as it is. E power mx is e power mx into mx derivative is m. Okay, I am doing the chain rule. So one after differentiation of a function, one after the other. Okay, so e power b into e power nx is b constant, e power nx into nx derivative is n. Again I will differentiate this with respect to x. So let us see what we will get. We will get the second order derivative, that is d square y by dx square. A and m both are constant. Keep that as it is. E power mx derivative is e power mx into mx derivative is m. Plus b into n is constant. Keep that as it is. E power nx derivative is e power nx into n. Okay. So what we will get finally? A m square e power mx plus b n square e power nx. This is second order derivative. Let me consider the left hand side of the given function. Okay, so left hand side, the given proof is d square y by dx square minus m plus n into dy by dx plus mny. So that can also be written as, let me substitute the d square y by dx square. So what we will get? A m square e power mx plus b n square e power nx. This is second order derivative minus m plus n. M plus n as it is, I will write down. Okay. So m plus n into dy by dx. Dy by dx is a m e power mx plus b n e power nx plus m n into y. See there, I will write down mn as it is. The y is a into e power mx plus b into e power nx. That is y value. Okay, let me simplify this. I'm simplifying. Okay, so first term a m square e power mx as it is I am writing plus b n square e power nx also as it is I am writing minus a m square. See, that is minus actually a m square e power mx minus a m n e power mx minus b m n e power nx minus b n square e power nx plus a m n e power mx plus b m n e power nx. Okay, see, every term will get cancelled. A m square e power mx, a m square e power mx plus minus b n square e power nx, b n square e power nx will get cancelled. A m n e power mx, this will also get cancelled. Every term will get cancelled. So that is equal to 0. This is what we are having in the right hand side. So this is what the proof. See, even this also, this problem is carries 5 marks. So first order derivative carries 1 mark, second order derivative 1 mark. Okay, with the simplification, that is another 1 mark. Then write down the left hand side, substitute the values, 3 marks. Multiply every term, finally it gets cancelled. For that it carries 2 marks. Okay, so totally it is a 5 marks question in second order derivative. Hope you understood very well. You please, if you have any doubts, put in the comment box. Okay. The next question is, if y is equals to sine inverse x whole square, then show that 1 minus x square into d square y by dx square minus x into dy by dx is equals to 2. See, actually, previous, that means I think the first problem is having sine inverse x, isn't it? So, this is sine inverse x whole square. There is a difference between both the problems. So, let us see the proof of this. If y is equals to sine inverse x whole square. So let me differentiate this function with respect to x, and let me find out the first order derivative. Dy by dx equals 2 into sine inverse x. See, first I'm considering the power. So this is in the form of x square derivative. X square derivative is 2 sine inverse x into sine inverse x derivative is 1 by root of 1 minus x square. So see, in the denominator, we are having root of 1 minus x square. So you just cross multiply that to left hand side. It becomes root of 1 minus x square dy by dx equals 2 times of sine inverse x. Again, let me differentiate this with respect to x to find the second order derivative. So see, actually in this problem, we must consider this as a product of two function and we should apply product rule. First function into derivative of second function plus second function into derivative of first function, that is 1 by 2 root of 1 minus x square into x square. One derivative is 0, x square derivative is minus 2x equals. In the right hand side, we are having 2 sine inverse x. Derivative is 2 into 1 by root of 1 minus x square. So see there, 2 gets cancelled. Let me simplify this. Before simplifying, again, in the right hand side denominator, we are having root of 1 minus x square. So I will multiply that to left hand side. For both the terms, I will multiply. Then let me see what we will get. Root of 1 minus x square whole square, because already we are having one term in the left hand side. So that's why it becomes whole square plus minus, see this negative comes outside, minus it becomes minus x into dy by dx into 1 by root of 1 minus x square. We are multiplying root of 1 minus x square, so equals 2. See here, this term gets cancelled. Okay, here square and root gets cancelled. I will write down the remaining terms, that is, here I'm writing 1 minus x square into d square y by dx square minus x into dy by dx is equals to 2. So this is the proof. Very simple actually. Scoring 5 marks in this problem is very easy. Don't be panic. You must practice very well. Okay. So if you have understood this question properly, you please like my video, share this video. Thank you.